Lesson number 3, let us talk about mathematical induction. At the end of this lesson, you will be able to demonstrate an understanding of the principles of mathematical induction, verify series using mathematical induction, and prove problem sets applying the principles of mathematical induction. Principles of mathematical induction. Let P be a proposition defined on the positive integers n. So when we say positive integers, they are exact numbers. That is, P of n is either true or false for each n is an element of natural numbers. Suppose P has the following two properties. Number 1, P of 1 is true. Then second one, P of k plus 1 is true. Whenever P of k is true, then P is true for every positive integer n, which is an element of natural numbers. Example number 1. P of n provided by 2 plus 4 plus 6 plus and so on and so forth up to 2n is equal to n times n plus 1. So in here, we have an arithmetic series. We have a series. When we say series, that is the sum of a sequence of numbers. Okay? Wherein we have provided at the right side of the equal sign the formula for getting the sum of this series. Specifically arithmetic kasi look at the numbers. We have here even numbers. Difference just 2. So first step, verify this case. So i-prove muna natin kung tama ba tong series na ito. So how to verify? First, you need to copy the first number in our series at the left side of the equal sign. So we have 2. Okay, so this one, it came here. Then afterwards, you need to verify this formula for getting the sum of the series. If n is equal to just one number, because we just have 2, 1 in our series, so replace n by 1. So using the formula n times n plus 1. So 1, 1 plus 1. So we have 1 times 2, the answer is 2. So verified. Correct. Another one. 2 in our series. Let us add. We have the first one is 2 followed by 4 and the sum is 6. Using the formula. So how many numbers do we have? At our left, 2 numbers. So n is equal to 2. So using the formula, at the right side for getting the sum of the series, you have n times n plus 1. Replace n by 2. So 2, then 2 plus 1. Then we have 2 times 3. The answer is 6. Okay, correct again. So 6 equals 6. Then how about 3 even numbers when we add 2 plus 4 plus 6? So the sum is 12. Well, let us verify if this is correct by applying the formula for getting the sum. So we have 3 numbers already. So n times n plus 1, replace n by 3. So 3 plus 1. So we have 3 times 4. The answer is 12. Correct. Then after we verify the formula for getting the sum and the series one by one at the left side of the equal sign, let us now apply the 2 rules of mathematical induction. P of k is true and also P of k plus 1 is true. We have P of n such that 2 plus 4 plus 6 plus and so on and so forth up to 2 plus n is equal to n times n plus 1. So first step, we need to have P of k first. Okay, so replace n by k. So it will become 2 plus 4 plus 6 plus and so on and so forth plus 2k. As I was saying, replace n by k is equal to k times k plus 1. Then afterwards, let us now have if P of k plus 1 is true. But let us show, replace n by k plus 1. Copy again, 2 plus 4 plus 6 plus and so on and so forth plus 2, replace n by k plus 1. So substitution, k plus 1 is equal to, in here, lahat ng n palitan ng k plus 1. So we have n first, then n plus 1, plus 1. So yung n magiging k plus 1, then k plus 1. Ayan. Okay, so as you combine all together, our p of k plus 1, which should be true. So let's write again, 2 plus 4 plus 6, plus and so on and so forth. Then plus 2k plus 1 is equal to k plus 1. Then k plus 1 plus 1, we can just write k plus 2. Then, as you can see here, this is the last number represented by 2k in our series as we add even numbers. And then, because kung siya yung dulo, di ba, ang dulo natin ay 2k. Eh kaso nagdagdag tayo ng isa. Kumbaga, kung meron tayong even numbers na 2, 4, 6, 8, 10, 12, 14, ina-assume natin yung 2k 14. Eh nagdagdag pa tayo ng another even. Ano ba kasunod ng 14? 16. Ina-assume natin 14, 16, kasunod na even na inad mo, ito, 2 times k plus 1. Ayan yung magkasunod. Kumbaga, ito yung second to the last. Ito yung pinaka-last na even. Okay? Tapos, kung ito yung pinaka-last na even, nagkaroon tayo ng bagong formula for getting the sum of the series, provided that we add another even number at the left side of the equal sign. So, ito na yung bagong formula ng sum. Okay? New. Okay? So, what we need to do now, kailangan natin pagsunurin yung ating second to the last even number saka last even number, represented by 2k saka 2 times k plus 1. So, ang mangyayari dito, magkakaroon tayo ng 2 plus 4 plus 6 plus and so on and so forth plus 2k plus 2 times k plus 1. Sila yung magkasunod. Diba? Is equal to yung bagong sum, which is k plus 1 times k plus 2. Okay? So, dalawang in-encircle ko na may check dun sa left side ng equal sign. Pinagsunod ko lang sila. As I was saying, yung 2k, ito yung second to the last. Itong 2 times k plus 1, ito yung last in the series, in our arithmetic series. So what we need to do now is we will do substitution. Okay, so ito mismo na binibilugan ko, which is sum of even numbers we considered as arithmetic series. Meron siyang formula ng sum. At ang formula ng sum niya ay ito. Kasi kung makikita nyo, ang ginawa ko lang substitution. Kung makikita nyo yung kaliwa, as a whole, ito. Nakikita nyo ba itong binibilugan ko? Ito mismo itong binilugan ko sa baba na naka-blue. Okay, so ang sum niya, by substitution, ay magiging k times k plus 1. Followed by, kakopy ko lang itong mga kasunod. 2 times k plus 1. Ayan, kinopya ko lang. Siya yung pinakadulo dun sa arithmetic series. Then, here is our sum. Just copy the rest. Okay? And then, let us prove if the new sum is correct by combining the left side of the equation. So, kung makikita nyo, magkaparehas ito. These are just the same. Nakikita nyo to? K plus 1 saka K plus 1. So, factoring by grouping, ang ginagawa pa ganito, pinagsasama yung nasa labas. Then, kinokopya yung kanilang common factor, which is a binomial, K plus 1. And then that is equal to k plus 1 times k plus 2. So kung makikita nyo, product naman niyan. So they are equal, so verified, correct. So that's how you prove using mathematical induction. Another example. Example number 2. Prove using mathematical induction that P of n given by this formula, sum. We have here sum of a series. 1 times 2 plus 2 times 3 plus and so on and so forth up to n times n plus 1, siya yung dulo. Provided the sum formula at the right side of the equal sign, 1/3 n times n plus 1 times n plus 2. So first step, you need to verify this one. Checking muna tayo. So when we say checking, what you need to do is you copy the first in our series, which is 1 times 2. Yan muna ko copyhin nyo. So as I copy, 1 times 2, alam nyo naman na 2. Okay, so ina-assume nyo isa lang yan. So n is equal to 1. Using the formula at the right side, 1/3 n times n plus 1, n plus 2. Kinokopya ko yung formula dun sa kanan ng equal sign. Replace n by 1. So 1/3 times 1 times 1 plus 1 times 1 plus 2. Okay, so cancel ito. Copy 1/3. So we have 1 plus 1 is 2. 1 plus 2 is 3. Cancellation method, cancel yung 3. Ano matitira? 2. So verified, correct? Correct. Okay, so another one. Let us try again, checking. Kahit man lang checking, magawa nyo kasi may point yan pag nagbigay ako ng activity. Let's see. 1 times 2, yung kasunod na. Isasama na natin itong kasunod. 1 times 2 plus 2 times 3. Ayan, diretso na yan. You just connect them. So I will write here 1 times 2 plus 2 times 3. So as you solve, 2 plus 2 times 3 is 6. So we have 8. Let's check if that is correct. Applying the formula. So n equals 2. Write the formula at the right side of the equal sign. So 1/3 n plus 1 times n plus 2. Replace n by 2. So 1/3 times 2, 2 plus 1 times 2 plus 2. So as you solve, 1/3 times 2, 2 plus 1 is 3, 2 plus 2 is 4. Cancel 3, so 2 times 4 is 8. Verified also, correct. How about the third one? Kung parang ma-verify mo talaga kung tama, di magdagdag ka pa ng isa doon sa ating series. 1 times 2 plus 2 times 3 plus 3 times 4. So we have 2 here, we have 6, we have 12. So as you add them all together, we have how many? 20. And then applying the formula, so we have here 3 numbers in our series. Applying the formula, 1/3 times n plus 1 times n plus 2. Replace n by 3. So 1/3 times 3 times 3 plus 1 times 3 plus 2. Okay, so 1/3 times 3 times 4 times 5. So cancel 3. So 4 times 5, 20. Verified, correct. We're done in checking. Let us now apply the rules of mathematical induction. P of k is true and P of k plus 1 is true. Given our problem. Given this, first step, let us have P of k. Supposedly, dapat ito ay true. Replace n by k. So, copy everything. 1 times 2 plus 2 times 3 plus and so on and so forth plus lahat ng n palitan ng k. So, k times k plus 1 equal sign 1/3 times k plus 1 times k plus 2. Yan muna. Then afterwards, let us have P of K plus 1. Supposedly, it should be true. Copy the rest again. 1 times 2 plus 2 times 3 plus and so on and so forth. Lahat ng n, palitan natin ng k plus 1. So, gagawa muna ako mga parentheses para hindi kayo nalilito. Equals 1/3. Ayan. 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 Ma'am, ano po ba yan? Di ba dapat itong una kong parentheses open and close n? E di lalagay ko k plus 1. Tapos itong pangalawa kong parentheses, di ba nakalagay dun sa taas na formula n plus 1? So yung n, papalitan ko ng k plus 1. Eh kaso, meron pa siyang plus 1. Okay? Then yung 1/3, katabi niya k sa kanan. So gagawin ko siyang k plus 1. Or n, rather n. Tapos yung n plus 1, gagawin kong k plus 1 plus 1. Tapos yung n ulit, k plus 1, then plus 2. Kasi may 2 sa dulo. Saka ko siya i-simplify. So we have 1 times 2 plus 2 times 3 plus and so on and so forth. K plus 1. O, k plus 1 plus 1. K plus 2 na lang to. Pinagsama na. Tapos ito, 1/3. Then k plus 1. O, k plus 1 plus 1. K plus 2 ulit. K plus 1 plus 2. So we have k plus 3. Ayan. As I was saying, meron tayong series. At sa series natin, sa P of K is true, dito tayo, ito yung dulo dun sa ating series. Na ito yung kanyang sum. Eh kaso, nag-add tayo ng another number. Kumbaga sa series natin na pinag-add, naglagay tayo ng panibagong number sa dulo. So nagkaroon na ng bagong dulo. Ito na siya. K plus 1 times K plus 2. Nanggaling siya dun sa taas na pinalitan natin yung n ng K plus 1. Sinimplify ko lang. Tapos, nagkaroon tayo ng bagong sum. Kumbaga, ito, para maintindihan, ito yung dating dulo. Yung chinecheck ko. Nagkaroon ng panibagong dulo kasi nga, K plus 1 na eh. Di ba from K, naging K plus 1. So, ayan yung panibagong dulo. Kumbaga, ito yung dating sum niya, formula ng sum ng series, nagkaroon ng panibagong sum. So, ngayon, i-connect ko, pagsasamahin ko, or pagsusunurin ko, yung dun sa series, yung P of K na K times K plus 1, saka yung dinagdag ko na panibagong number sa series. So, as I write it, dito ka magsimula. 1 times 2 plus 2 times 3 plus and so on and so forth plus, ito yung dating dulo. O, naintindihan? Galing siya sa P of K. Tapos, ipa-plus mo yung bagong dulo. Galing siya sa P of K plus 1. Yung bagong dulo niya, ito na siya. So, K plus 1 times K plus 2. Siyempre, nagkaroon ng bagong sum. So, doon ka magpo-focus sa bagong sum kasi nadagdagan na siya ng isang number eh. So, 1/3 times K plus 1 times K plus 2 times K plus 3. Tapos ngayon, gagamitin natin yung substitution ngayon. Ito mismong 1 times 2 plus 2 times 3 up to K times K plus 1. Ito yan, di ba? Am I right? Tapos ito yung kanyang old sum. Ito yung dati niyang sum. So ipapalit ko to, itong ini-encircle ko ng green. Doon sa nasa baba na nakabilog din ng green. Substitution. So substitute ko yung sum niya dati. So I will write 1/3 K times K plus 1 times K plus 2. Then copy the rest. Copy everything until the end. So inad mo. Yung old sum, sinama mo yung panibagong number na dinagdag mo sa dulo. Siyempre, magkakaroon na ng panibagong formula ng sum. So, just copy the rest. Okay? Then, what you need to do, kailangan ma-verify niyo yung new sum. Itong nasa kanan, kailangan ma-verify niyo to by combining this nasa left side. O ma'am, paano mo ba kino-combine nasa kaliwang bahagi? O, tingnan mo yung common factor nila. Kung makikita niyo, meron silang common factor, binomials. Ang common dito, ito, k plus 1 times k plus 2, k plus 1 times k plus 2. Okay? So, we have two terms. So, ang gagawin nyo lamang, ina-assume nyo, ito yung first term, ito yung second term. Okay? So, ang gagawin nyo dito, may common factor. So, ilalabas nyo yung common factor nila. Ang common factor nila ay k plus 1 times k plus 2, nakabilog ng purple. So, labas ko muna. K plus 1 times k plus 2. Once. Tapos, yung bawat term na yan, i-divide ko dito sa common factor nila na binomials, dalawang binomials. So, 1/3 k lahat 1/3 k kasama yung common factor divided by yung common factor na matitira. So, matitira ay 1/3 k. Okay, plus, itong symbol na plus, copy. O, k plus 1 plus k plus 2, yung second term, i-divide mo sa sarili. O, parang 8 divided by 8, 1. So, malalagay mo dito 1. Okay? Then, kung makikita niyo yung nasa kanan na formula, hindi pa pareho. So, anong gagawin ko? So, what we need to do, kailangan kong ilabas yung 1/3. So, ilalabas ko tong 1/3. Ayusin ko siya, unahin ko nga muna siya dito. Pagsunod-sunurin ko. Ayan. Pinag-ayos ko lang yung ating mga factor. So, ilalabas ko yung 1/3. So, itong 1/3 k plus 1 na ito, kung makikita nyo, this one, i-divide ko bawat term sa 1/3. So, 1/3 k divided by 1/3. Anong sagot? O, di makakancel yung 1/3, matitira k na lang. O, plus 1 divided by 1/3. Ma'am, ano po ba yun? 1 divided by 1/3. O, di ba pag nag-divide tayo ng whole number sa fraction, copy the whole number, tas magiging times, reciprocal. Hindi sagot 3. Gumamit kayo ng calcu pag hindi maintindihan. O, 3. Then copy the rest. Okay. So, parehas na ba sa chinek ko sa kanan? Di ba nakita niyo yung 1/3, k plus 1, k plus 2, k plus 3. Ito rin. Nauna lang yung k plus 3, pero parehas sila. So, ibig sabihin, verified. Correct. So, tama. Tama nga yung ating bagong formula ng sum nung ating series. So, alam ko mahirap ito. So, sana naunawaan nyo. Pag-aralang mabuti. Magbibigay ako ng activity regarding this. Thank you, class.